Good morning everyone. For today's vlog, we're going to tackle all about ore deposits and economic minerals. We mine many minerals from earth. Some ores are valued for their mineral properties, some of the elements they contain, and other because they contain valuable gems. The best ore deposits are those containing large amount of minerals. Mineral resources. Earth gives us many mineralogical resources, also called mineral commodities. For well than a dozen minerals and 8 or 9 elements dominate the crust. We use most of them in our daily lives. Other elements and minerals that exist only in a small amount and have an even distribution are equally vital. We mine some ores because they contain elements that have the metallic properties of conductivity, strength, or shining appearance. We mine industrial materials such as halides, gypsum, clays, calcites, asbestos, micas, and joolites to make salt, plaster, ceramics, construction materials, electronic components, chemical filters, and many other things. We mine diamonds and other potential gems for jewelry and other for use in industry. At this figure, it shows the diamond mine in remote Canada. This mine has produced about 10 million carats of rhombic diamonds since it began operation in 2003. Ore deposits and ore minerals fall into several many commodities groups. The table here shows the group of mineral commodities. First group of mineral commodities are metallic and semi-metallic elements. Their examples are gold, silver, copper, iron, manganese, and aluminum. Second is non-metallic elements. Their examples are potassium, sodium, phosphorus, and sulfur. Next is the gems. Gems are the diamond, sapphire, and agates. Another is industrial materials in construction and manufacturing, like sand, clay, buildings, stone, diatomites, talc, mica, and jolt. Another industrial materials and fertilizer and chemicals like limestones, phosphate, potash, salt, nitrates, and chlorides. And last is the energy resources like coal, oil, gas, and uranium. The history of mining. Since mining is nothing new, people have practiced mining and quarrying since ancient time. The first mineral known to be mined was flint, a fine-grained variety of quartz used to make weapons. Early people mined other things, such as ochre, for use as pigments in art of religious ceremonies. Archaeologists and anthropologists define major periods of human civilization based on resources used. There is a great deal of overlap in different regions, moved from other period to another at different times. The Late Stone Age is also called Neolithic Age and followed by the Paleolithic Age, from 4500 to 3500 BCE or before Common Era. At this figure, it shows the artifact from Bronze Age, the age that followed Paleolithic Age, and the last from about 4200 to 1000 BCE. Perhaps, most of the significant advance in metal use was the discovery of how to make bronze and alloy created by the melting and combining the metal copper and tin. So, tin melts at a relatively low temperature of 232 degrees Celsius, and copper melts at 1983 degrees Celsius at a temperature too great to be easily achieved at the time. However, clever metal workers discovered that a mix of 1 part tin and 3 parts copper melts at 1675 degrees Celsius, which was low enough to make a bronze manufacturing possible in many places. At this map figure, it shows the location of Bronze Age mine that provides metal use throughout much of Middle East, where most of the copper came from the Traidos mountain of Cyprus, where copper could be found in loose sediments of Earth's surface. At this next figure, it shows the Iscariotisa mine, which was site of Bronze Age mining and an active mine today. The Iron Age, followed by the Bronze Age, beginning around 1500 BCE, when the Hittite society of ancient Anatolia, or modern-day Turkey, discovered how to process iron. Their technological breakthrough was to add small amount of charcoal, or which is the carbon, to rock the contained iron. Pure iron melts at 1538 degrees Celsius, but adding carbon results in the carbon iron mixture that melts at 1170 degrees Celsius. The Hittites also figured out that the iron-carbon alloys cannot be cold, work like a bronze, but to be harmed and shaped while it's hot. The source of iron used by the Hittites was metallic meteorites. Meteorites also contains a small amount of nickel that improve metal properties. Because iron is rich of meteorites was not in abundance. However, by 1200 BCE, iron metal working technology had spread across the Middle East, North Africa, Europe, and to Asia. People discovered new resources of iron and the Hittite Empire disappeared. Egyptians mined native metals including gold, silver, and coppers from steam beds as early as 3700 to 3000 BCE. Around 2600 BCE, they began to quarry stones to build the Great Pyramids. By the Middle Age, mining was common in Europe. It's according to Georgius Agricola. Copper, tin, iron, and nickels were all important during the early ages of humans, and they are quality potent today. Those same metals and many others are key parts of seeming infinite numbers of products. For example, our smartphones. Our smartphones contains all of these minerals. So let's continue to mineral deposits, ore deposits, and mining. Mineral deposits is a place in earth crust where geologic processes have concentrated one or more minerals at greater abundance than in an average crust. An ore deposit is a mineral deposit that can be produced to make a profit. Thus, all ore deposits are minerals deposits, but the reverse is not true. Mining operations have many guesses. Surface mining involves uncovering resources by removing overburdens. This is done in several ways, but for metal deposits, open pit mining is almost common. This is the Bigham Canyon mine near at Sri Lanka Lake is the world's deepest open pit. It is 4.5 km by 1.3 km in area and in 1.2 km deep. Since mining began just over 100 years ago, the Bigham Canyon open pit was produced 24 million tons of copper, 790 tons of gold, 6,600 tons of silver, and 425,000 tons of molybdenum. Thus, to maintain our societies and lifestyles, without recycling metals, the world people needs many mines like one of Bingham Canyon. At this figure, it shows the Mponing gold mine of southwest of Soderberg, South Africa. It is the deepest mine in the world. At this photo shows the tailing at the mine just south of Quebec City, Quebec. So let's continue to the natural abundances of elements. At this table, natural abundance, economical ore grade, and concentration factor for some metals. It contains ore resources, metal concentration in average crystal rock, minimum ore grade for profitable extractions, and economical concentration factor. Many gold mines can remain profitable even if ore contains less than a 0.1 ounce of gold in a ton of rock. At this figure, it shows the example of gold ore from Greenland. The gold flakes are small. The entire photo is less than 2 centimeters across. Worldwide distribution. Geological processes that concentrate minerals are not unusual, but the process that create economical economically productive ore deposits are rare. If they were not, market prices would fall, decreasing profits and putting some mines out of business. At this figure, it shows the Climax mine of Colorado. This mine has historically been the largest producer of molybdenum in the world. Production started in 1915, but the mine temporarily shut down between 1995 and 2012 due to low molybdenum prices. Additionally, we imported many minerals commodities that we might produce ourselves because it would cost too much to mine them in our own country. Ore minerals. Ores and ore minerals vary greatly in quality. Ideal ore contains 100% ore minerals. Such ore does not exist, but some come close. The table here shows the list of common ore minerals for various metals. The minerals include the native metals, copper and gold, and many sulfides, oxides, and hydroxides. Native elements, metals, semi-metals, and non-metals. Native elements have high value because they may require no processing because being used in manufacturing, as currency, or for other purposes. The first metals ever used by humans were native metals. We conveniently divided native elements into metals, semi-metals, and non-metals based on their chemical and physical properties. The table here shows the native metals, native semi-metals, and native non-metals. Native copper, gold, silver, and platinum have a tonic structure with atom arrangement in a tube pattern. This figure, iron does. 2. Although native irons is rare, except in meteorites, and the atomic arrangement in native iron is not quite as the same as in the other metals. Nonetheless, hydride crystal of any of these minerals may be cubic or, as we'll explain in the next chapter. Native zincs are very rare minerals, made a hexagonal atomic arrangement and so for crystal of different shapes. The photos here shows the examples of native gold, silver, copper, platinum, antimony, and so forth. Sulfides and sulfur salts. Metallic ore deposit contains many different sulfides and related to ore minerals. Most are quite rare. Oxide and hydroxide. We often group oxides and hydroxides together because they have similar composition and atomic arrangement. Gems and gem minerals. Gems are precious or semi-precious stones and related substances that can be cut or polished to use for ornamentation.